Hello everyone. Welcome to SWAM's online lecture series on the topic Database Management System. My name is Maulana Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University, Aligarh. I am welcoming you all in this lecture. In this lecture, we will discuss interesting topics including data modeling using relational calculus. So let's begin the lecture of today. In the last lecture, we have discussed data file and types of data file. Before proceeding with today's agenda, I would like to discuss some questions that I had given you in the last class. The first question was, what do you mean by secondary data file, and explain it in detail. The answer is, in database management system, the secondary file refers to an additional file or files used to store users' data and database objects apart from the primary data file. Secondary data file, also known as NDF files, provide a means to expand the storage capacity of a database beyond the limitation of a single file. They are typically used in scenarios where the primary data file becomes a full, or when administration want to distribute data across multiple disks for performance or administrative reasons. Secondary data file contains tables, indexes, and other data objects contributing to the overall data storage and management within the database system. The next question was, describe transaction log file in detail. The answer is, in database management system, a transaction log file is a crucial component responsible for recording all changes made to the database. It captures detail of every transaction, including inserts, updates, and deletes in a sequential manner. This log file ensures data integrity and recovery. The log file ensures data integrity and recoverability by providing a reliable record of database modification. In the event of system failure or data corruption, the transaction log file enables the system to restore the databases to a consistent state by replacing or undoing transactions. Additionally, it facilitates features like point-in-time recovery, replication, and database mirroring, enhancing data reliability and availability in database management environment. Now, the important topic of today's lecture is the advanced relational calculus. Relational calculus is a formal method used to database management system to specify queries for retrieving data from relational database. It usually defines a non-procedural approach which does not follow any procedure to query formulation, focusing on describing what is desired rather than how to retrieve it. Relational calculus offers a powerful and expressive framework for specifying queries in relational databases. Its declarative nature, variable binding, use of qualifier and predicate logic, expressive power, theoretical foundation, and equivalence to relational algebra make it an indispensable tool for database query formulation and optimization. Some characteristics of relational calculus are declarative nature, variable binding, quantifier, predicate logic, expressive power, theoretical foundation, and equivalence to relational algebra. Relational calculus is equivalent to expressive power to relational algebra, another formal method for specifying queries in relational database. This means that any queries expressible in relational calculus can be expressed in relational algebra and vice versa. Overall, relational calculus offer a powerful and intuitive way to specify queries in relational databases. It is declarative nature, variable binding, use of quantifiers and predicates logic, expressive power, and theoretical foundation make it an essential concept in understanding and working with relational databases. What are the types of relational calculus? In database management system, relational calculus is a formal language used for querying and manipulating data stored in relational databases. There are two main types of relational calculus. First is tuple relational calculus, we can say it is TRC. The next is domain relational calculus, we can say DRC. Tuple relational calculus, and the next is domain relational calculus. Tuple relational calculus. Tuple relational calculus is a formal language used for querying and retrieving data from relational databases. TRC operates on the tuples of relation in a database and allows user to specify the desired properties of the tuples they want to retrieve without specifying how to retrieve them. Let us delve into the detail of TRC. Syntax. TRC queries are expressed as formulas that describe the condition or properties of the tuples to be retrieved. The syntax of TRC involves qualifier for existence and for universal, and logical connectives and or not to specify conditions on tuples. TRC queries can include variables to represent tuples and attributes as well as constant and comparison operators. Qualifiers. TRC queries use qualifier to specify the scope of conditions imposed on the tuples. The existence qualifier is used to specify that there exists at least one tuple satisfying the given condition. The universal qualifier is used to specify that all the tuples specify the given conditions. Conditions. TRC queries specify conditions that tuples must satisfy to be included in the result. Condition can involve comparisons, for example, equal, not equal, logical operators like and, or, not, arithmetic operations and other related operators, for example, greater than, less than. The next is declarative nature. TRC is declarative nature, meaning TRC is declarative language, meaning that users specify what data they want without specifying how to retrieve it. User focus on describing the desired properties of the tuple and the database system determining the most efficient way to retrieve the data based on the query. The next is query execution. When a TRC query is submitted to a database, the system parses the query, validates its syntax and semantics, and translates it into an execution plan. The execution plan specifies the steps the database system needs to take to retrieve the requested data, such as scanning the appropriate relations, applying filter, and performing any necessary join or aggregation. Optimization. Optimization techniques may include query rewriting, predicate pushdown, join reordering, and index selection to minimize resource usage and query execution time. Tuple Relational Calculus provide a formal and declarative language for query relational databases by specifying conditions on tuples to be retrieved. TRC allows users to focus on describing their information needs while the data system handles the detail of query execution and optimization. The next is Domain Relational Calculus. Domain Relational Calculus is another formal language used for querying data in relational databases, while TRC operates on tuples of relations. Domain constraint Domain Relational Calculus focuses on individual attributes of a relation. Let us explore Domain Relational Calculus in detail. Conceptualization. In DRC, you are essentially describing the properties of attributes within the database rather than the tuples themselves. It's like asking questions about specific characters of data, such as what are the name of the all employee, or what is the highest salary in the sales department. Syntax. The RC queries are expressed as formula that describes the properties of the values in the domain of attributes. Similar to TRC, the RC uses qualifiers for existence or for universal and logical connections and or not to specify conditions or attributes. Qualifier. Quantifiers. Quantifiers in database. Quantifiers in DRC work similarly to TRC but apply to attributes instead of tuple. Conditions. Conditions in DRC describe the properties that attributes value must satisfy. These conditions can involve comparison, logical operations, and other relational operators, just like in TRC. The next is declarative nature. DRC, like TRC, is a declarative language. You specify what data you want, and the database system figure out how to retrieve it. Next is query execution. When you submit a DRC queries to database system, it parses the query, validates its syntax and semantic, and translate it into execution plan. The execution plan specifies how the database system retrieves the requested attributes value, such as scanning the appropriate relations and applying filters. Next is optimization. Database system often optimize DRC queries to improve performance. DRC allows user to query relational databases by specifying conditions on individual attributes. It provides a structured way of asking questions about the properties of attributes value within the date. It provides a structured ways of asking question about the properties of attributes value within the data. Now let us discuss the key features of relational calculus. It includes the following, which you can see on a screen: query optimization in data modeling, in database integrity, tool and frameworks in NoSQL database. Relational calculus query optimization. Relational calculus may be defined as a non-procedure query language that describes what data to retrieve from the database without specifying how to retrieve it. There are two main variants of relational calculus: tuple relational calculus and domain relational calculus. Query optimization in relational calculus involves finding the most efficient way to execute a query without minimizing resource usage such as CPU time, memory, and disk input output. Here's, here is a detailed explanation of query optimization in detail calculus. We will discuss in detail explanation of query optimization in relational calculus in the context of database management system, parsing, query analysis, query transformation, cost estimation, query plan generation, next is plan selection, plan execution, and adaptive optimization. In some advanced database management system, query optimization is not a one-time process but ongoing activity. The system may adaptively adjust the query plan based on running time statistics and feedback to improve performance dynamically. Overall, query optimization in relational calculus involves a series of steps starting from query parsing and analysis to cost estimation, plan generation, selection, and execution. The goal is to find the most efficient way to retrieve data from the database while minimizing resource usage and maximizing performance. Next is relational calculus in data modeling. Relational calculus plays a fundamental, or we can say vital role in data modeling within database management system. Data modeling involves defining the structure and relationship of data in database, and relational calculus provides a formal language for expressing queries and const. Relational calculus provide a formal language for expressing queries and constraints on the relational data. Let us explore how relational calculus is used in data modeling in database management system in detail. Defining relational and attributes, querying data, data manipulation and transformation, next normalization and database design, database query optimization. Relational calculus is integral of data modeling in database management system as it provides a formal language for defining relations, query database, expressing constraints, and designing databases. By leveraging a relational calculus, database designer can create robust, efficient, and well-structured databases that meet the need of our applications. Relational calculus and database integrity. Relational calculus and database integrity are closely related concepts in database management system. Relational calculus provides a formal language for expressing queries, constraints, and rules governing the integrity of data stored in a relational database. Let's explore the detail how a relational calculus contribute to ensuring data integrity. Relational calculus allows user to define constraints that enforce the integrity of the database schema and the data stored within it. Common constraints include primary key constraints, foreign key constraints, unique constraints, check constraints. Enforcing data integrity using relational calculus, database normalization, and the last is integrity check. Optimization techniques such as query rewriting and index selection help ensure that integrity constraints are enforced without compromising query performance. Relational calculus plays a crucial role in ensuring database integrity by enabling the definition of constraints, enforcement of data integrity rules, expression of business rules, normalization of the database schema, and optimization of integrity checks during the query execution. By leveraging relational calculus, database management system can maintain the consistency, accuracy, and the reliability of data stored in relational database. Now, after learning the advanced topics, we have to know the relational calculus tools and frameworks. Relational calculus tools and frameworks in database management system provide environment for creating, executing, and optimizing queries expressed in relational calculus language. These tools offers a range of features to assist database administrator, developers, and users in query and managing relational databases efficiently. Let us explore in detail some of the key tools and frameworks. Let us explore in details some of the key tools and frameworks associated with relational calculus in DBMS. Relational calculus interprets query optimization frameworks, relational algebra converters, database management system, query execution plans, visualization tools. Overall, these tools and frameworks make it easier to work with databases, ask questions effectively, and get the information you need quickly and accurately. Relational calculus in NoSQL databases. Let's explore how relational calculus concept can be adopted and applied NoSQL databases. First is document oriented databases. NoSQL databases like MongoDB and Couchbase use document-oriented data models where data is stored as JSON-like documents instead of tables. Relational calculus can be adopted to query document orientation database by treating documents as tuple and their fields as attributes. Graph databases. NoSQL graph databases like New4G, store data as needs. NoSQL graph databases like New4J store data as a node and edges, representing entities and relationships in a graph structure. Relational calculus concepts can be applied to graph databases by formulating queries that traverse nodes and edges to retrieve relevant information. TRC queries in graph database may involve specifying conditions on node and edge properties and using quantifier to navigate the graph structure. Next is key value store, query language and APIs. Schemaless nature. NoSQL database often have a schemaless or flexible schema model allowing for dynamic changes for data structure. Relational calculus, which relies on the fixed schema and well-defined relation, may need to be adopted to accommodate the schemaless nature of NoSQL database. While the traditional relational calculus concept may need adaptation, they can still be applied in NoSQL databases to formulate queries and retrieve data effectively. The key lies in understanding the data model and querying capabilities of the specific NoSQL databases and leveraging appropriate query language, APIs, and query techniques to achieve desired results. In today's lecture, we discuss detailed description of relational calculus. Now let us access your knowledge and track your progress with some important questions. Your answer will enhance your concepts as well as make you more aware about the topic. The today's question to test your knowledge are: explain relational calculus and its type in detail. What are the key features of the relational calculus and explain in detail. In our exploration today, we have gone through the conceptual and fundamental explanation of the data modeling using the relational calculus. In today's lecture, we have discussed so many topics. In today's lecture, we have discussed so many important topics which will help you to understand the concept of relational calculus using data modeling. I hope you enjoyed this lecture. Keep practice and I wish you to see you in the next lecture. Thank you.